Hello students, myself Surbhi Singh. I am Assistant Professor at Aryabhatta College of Engineering and Research Center. This video is about distributed system. What is distributed system? A distributed system is a collection of independent computers that appears to its users as a single coherent system. This definition has several important aspects. First one is that a distributed system consists of components that are autonomous. A second aspect is that users think they are dealing with a single coherent system. This means that one way or the other, the autonomous components need to collaborate. This diagram shows how a distributed system organized as middleware. We can see 4 networked computers and 3 applications, out of which application B is distributed across computer 2 and 3. Computer 1, computer 2, 3, 4 and application A, application B, application C. Each application is offered the same interface. The distributed system provides the means for components of a single distributed application to communicate with each other, but also let different applications communicate. Goals of distributed system. First goal is making resource accessible. The main goal of a distributed system is to make it easy for the users to access remote resources and to share them in a controlled and efficient way. Resource can be just about anything, but typical examples include things like printers, computers, storage facilities, data files, web pages and networks. For example, it is cheaper to let a printer be shared by several users in a small office than having to buy and maintain a separate printer for each user. Second goal is distribution transparency. An important goal of a distributed system is to hide the fact that its processes and resources are physically distributed across multiple computers. A distributed system that is able to present itself to users and applications as if it were only a single computer system is said to be transparent. Okay, now third goal is openness. Another important goal of distributed system is openness. An open distributed system is a system that offers services according to standard rules that describe the syntax and semantics of those services. For example, in computer network, standard rules govern the format, content and meaning of messages sent and received. Such rules are formalized in protocol. Okay, next goal is scalability. Scalability is one of the most important design goals for developers of distributed system. Scalability of a system can be measured along at least 3 dimensions. Okay, first one is system can be scalable with respect to its size, and second is a geographically scalable system is one in which the users and the resources may lie far apart, and the third one is system can be administratively scalable, means that it can still be easy to manage even if it spans many independent administrative organizations. Okay, next is pitfalls, means we have to make some false assumptions while designing distributed system. Uh, uh, some of them are that the network is reliable, the network is secure, and homogeneous. The topology does not change, latency is zero, bandwidth is infinite, transport cost is zero, and there is only one administrator. Okay, next is types of distributed systems. Okay, so there are three types of distributed system. First one is distributed computing system, second is distributed information system, and third is distributed pervasive system. Distributed computing system is an important class of distributed system, is one used for high performance computing tasks. So this is further divided into two categories: cluster computing and grid computing. Distributed information system is what which is further divided into two categories. First one is transaction processing system and second is enterprise application integration. And the third type of distributed systems is distributed pervasive system, which the example of this is home systems, healthcare systems and sensor network. So let's move on to the first part of distributed system, distributed computing system. And a part of this type of DS, I mean distributed system, is cluster computing system. Now what is cluster computing system? Cluster computing system became popular when the price and performance ratio of personal computer and workstation improved. At a certain point, it became financially and technically attractive to build a supercomputer using off-the-shelf technology by simply hooking up as a collection of relatively simple computers in a high-speed network. Okay, this diagram shows us the concept of cluster computing. In this diagram, each cluster consists of a collection of compute nodes that are controlled and accessed by means of a single master nodes. Okay, this is single master node, and these compute nodes are controlled by this master node. The master typically handles the allocation of nodes to a particular parallel program, or maintains a batch queue of submitted jobs and provides an interface for the users of the system. Okay, next is second part of distributed computing system is grid computing system. What is grid? A characteristic feature of a cluster computing is its homogeneity. In most cases, the computers in a cluster are largely the same. They all have the same operating system and are all connected through the same network. In contrast, grid computing systems have a high degree of heterogeneity. No assumptions are made concerning hardware, operating systems, networks, administrative domains, security policies, etc. So this is the diagram of grid computing system. Actually, it is a layered architecture for grid computing system. In this, the lower layer is fabric layer. So fabric layer provides interface to local resources at a specific site. Next is connectivity layer. It consists of communication protocols for supporting grid transactions that spans the usage of multiple resources. Next is resource layer. It is responsible for managing a single resource. And next is collective layer. It deals with handling access to multiple resources and typically consists of services for resource discovery, allocation and scheduling. Last is application layer. It consists of applications that operate within a virtual organization and which make use of the grid computing environment. Okay, now the second type of distributed system, distributed information system. So first type of distributed information system is transaction processing system. What is transaction processing system? In practice, operations on a database are usually carried out in the form of transactions. Programming using transactions requires special primitives that must either be supplied by the underlying distributed system or by the language runtime system. This is the diagram of transaction processing system. In this diagram, a component which is called transaction processing monitor, TP monitor, its main task was to allow an application to access multiple server and databases by offering it a transactional programming model. We can see server 1, 2, 3, and this is client application. So client application is making request to transaction processing monitor, and it then requests server 1, server 2, server 3, and these servers are connected to their respective databases. Now they further reply, each server replies, and this TP monitor the reply collectively to client application. Next is enterprise application integration. Application components should be able to communicate directly with each other and not merely by means of request or reply behavior that was supported by a transaction processing system. This need for inter-application communication lead to many different communication models. Okay, this is the diagram of enterprise application integration. In this diagram, you can see this is communication middleware, and these two are client applications. Okay, now these are server side applications which are having their database separately. So here communication middleware can be RPC, which is called remote processor calls. An application component can effectively send a request to another application component by doing a local procedure call, which result in the request being packaged as a message and sent to the callee. Okay, now next type is distributed pervasive system. This is third type of distributed system, and its first example is home system. Okay, distributed pervasive system are often characterized by being small, battery powered, mobile, and having only a wireless connection, although not all these characteristics apply to all devices. Moreover, these characteristics need to necessarily be interpreted as restrictive. Okay, so what is home system? An increasingly popular type of pervasive system, but which may perhaps be the least constrained system built around home system. These systems generally consist of one or more personal computers, but more importantly integrate typically consumer electronics such as TVs, audio, video equipment, gaming devices, smartphones, and other personal variables into a single system. Okay, in this diagram we can see this is internet, and refrigerator, telephone, television, camera, computer, these are in home network, and these all are connected to internet via home gateway. Okay, internet is connected to service provider, and smartphone and PDA are also connected with internet. Okay, second type of distributed pervasive system is electronic healthcare system. It is another important class of pervasive system. With the increasing cost of medical treatment, new devices are being developed to monitor the well-being of individuals and to automatically contact physicians when needed. In many of these systems, a major goal is to prevent people from being hospitalized. Personal healthcare systems are often equipped with various sensors organized in a body area network, which is called BAN. Okay, body area network BAN. An important issue is that such a network should at worst only minimal hinder a person. Okay, in diagram A central hub is part of the band and collects data as needed. Okay. From time to time, this data is then offloaded to a larger storage devices. The advantage of this scheme is that the hub can also manage the band. Band means body area network. Now in second diagram, in this scenario we can see the band is continuously hooked up to an external network, again through a wireless connection, to which it sends monitored data. Okay, so there is transmitter and it is all scenario of wireless connection. Okay, so next type of distributed pervasive system is sensor networks. This is our last example of pervasive system. These network in many cases form a part of the enabling technology for pervasiveness, and we see that many solutions for sensor networks return in pervasive applications. What makes sensor networks interesting from a distributed systems perspective is that in virtually all cases they are used for processing information. In this sense, they do more than just to provide communication services, which is what traditional computer networks are all about. So, we can see in this diagram, first, sensors do not cooperate but simply send their data to a centralized database. We can see they are not cooperating themselves, but they send their data to a centralized database or operator site. The other extreme is to forward queries to relevant sensor and to let each compute an answer, requiring the operator to sensibly aggregate the returned answers. Okay. The first one requires that sensors send all their measured data through the network. Okay. Which may waste network resource and energy. And this second solution may also be wasteful as it discards the aggregation capabilities of sensor, which would allow much less data to be returned to the operator. So what is needed are facilities for in-network data processing, as we also encountered in pervasive healthcare system. So this is all for today. This is all about distributed systems. Thank you.